Hello there, math leads. Welcome back to Math Jamboree. In this video, we have another AP pre-calculus type of a question from the topic of equivalent representations of polynomial and rational expressions. Let's solve it together. Given f of x equals x minus 4 times x plus 2 over x minus 4 times x minus 1, describe the graph. A. The graph has a hole at x equals 4 and the vertical asymptote at x equals negative 2. B. The graph has a hole at x equals negative 2 and the vertical asymptote at x equals 4. C. The graph has a hole at x equals 4 and the vertical asymptote at x equals 1. And D says the graph has no holes or vertical asymptotes. So, to solve this question, and if you're talking about a hole, when does the hole becomes? Then you must have the same expression in the numerator and the denominator to cancel it out. During that condition, then that's the hole becomes. And also, for the vertical asymptotes, we are just only focusing on the denominator section. And when we solve the expressions for x by making the equal 0, in the denominator, we find the vertical asymptotes. So you can see that x equals 4 and x equals 4 canceling each other out. So we're talking about a hole now. When you solve it for x equals 4, there is a hole at x equals 4. For the vertical asymptote, x minus 1 equals 0. You can add 1 to both sides. And x equals 1. So this is vertical asymptote. So we have x equals 1 vertical asymptote, and there is a hole at 4. So let's go through the choices. The graph in choice A, it says x equals 4 hole, vertical asymptote at x equals negative 2. No, this is incorrect. The graph has hole at x equals negative 2. No. So the graph has a hole at x equals 4 and the vertical asymptote at x equals 1. This matches with our analysis. And choice D is not the correct answer. So the correct answer is choice C for the specific question. I hope you found this video helpful. If you did, please give it a thumbs up. If you have questions or comments, you can always leave it below there. Thank you and see you next time. Bye-bye.